So this is the 39th video on rigid body kinematics. This is in continuation of the 38th video. So in this also I'll take up problems on instantaneous center of rotation. Okay, location of instantaneous center of rotation by several different methods, in which the rolling body rolls with slip over a translating plank. Okay. So again, before going ahead, I'll say two things. First, that all these videos have been put in the playlist of rigid body kinematics. You can go and access all of them. And if you understand all these videos properly, you don't have to go anywhere else. It's more than sufficient. You understand all this and take a problem for any other source, you will be able to solve them. In case you have difficulty, you write in the comment box, I'll answer it. Okay. So I'll take a problem on this, some more problems. Okay. So first I'll write down the question. A circular drum with center at C and radius R rolls with slip over a translating plank. All the velocities are with respect to ground. In each case, find the location of IC of drum, IC meaning instantaneous center, with respect to first ground and second with respect to plank P. Okay. Of IC of drum with respect to first ground and second with respect to plank P. Okay. So two problems will be taken up. So first problem I write down. This is the first problem. This is a translating plank. Okay, fine. This is the center C of the drum, R is the radius. Center C moves at a speed of 7v with respect to ground. This is the material point D1 of the drum in contact with material point P1 of the plank. Plank translates at a speed v with respect to ground, and point D1 of the drum moves rightward at a speed of 3v with respect to ground. Okay. Now in this case we have to specify, we have to locate the IC of drum with respect to ground and with respect to plank in terms of distance r. Okay. So first we'll solve part A. We'll determine the IC of the drum with respect to ground. IC of drum with respect to ground. IC of drum with respect to ground, that we have to locate. Okay. And this is located by several different methods. Okay. By several methods I add here. By several different methods. Okay. So this will determine. Okay. So now first P1 is the material point of plank in contact with material point D1 of the drum at the given instant. Alright. So now we'll determine. Okay. So first we have to determine the IC of drum with respect to ground. But before that we must note that if we have to determine the IC of drum with respect to ground, then all the velocities have to be taken with respect to the angular velocities have to be taken with respect to ground. This point you must understand. If you have to determine the IC of drum with respect to ground, then all the velocities and angular velocities appearing in the calculation must be taken with respect to ground frame. Alright. So all these velocities are already given with respect to ground frame. Okay. So I'll solve this by method 1 first. Okay. I'll draw the line CD1. CD1 is a line fixed in the drum. Okay. Now C is moving rightward at a speed of 7v with respect to ground, and D1 is moving rightward at a speed of 3v with respect to ground. Okay, fine. So now see, in this case, if you take a point P here, P dash, say at a distance of y dash, then velocity of P dash is a linear function of y dash. So if y dash is 0, then P dash is C, then velocity of P dash is 7v, right? If y dash is r, then P dash is D1, velocity of D1 is 3v rightward, and velocity of P dash is a linear function, continuous function of y dash. So if at y dash 0 velocity is rightward and y dash equal to r velocity is also rightward, and less than that, then velocity of point which becomes 0 should be below d1. So 0 velocity point of drum which should be below d1. So that is IC of drum with respect to ground should be below d1. So this is where the IC should be. This is the IC of drum with respect to ground. Is it alright what I have said here? IC of drum with respect to ground is at a distance y1 below d1 say. Okay. Now we have to determine y1 by several different methods. Now in this case you can see center is moving rightward at 7v, d1 is moving rightward at 3v. So rotation of drum will be omega will be clockwise. Okay. So now d1 is at a distance of y1 from IC. So from IC concept, omega y1 is the velocity of d1, which is simply 3v. And center C is at a distance of r plus y1 from IC. So velocity of center will be omega into r plus y1, that is same as 7v. Alright, now if you divide these two, omega will go away. R plus y1 by y1 is equal to 7 by 3. This means 3r plus 3y1 is equal to 7 by 1. This means y1 is equal to 3r by 4. Answer. IC of drum with respect to ground is at a distance of 3r by 4 below d1. Okay. This is the answer to first part of question by method 1. Okay. Fine. So this error bit now. So we solve the same question by method 2. See, method 1 we write down two equations for this, and then we solve them simultaneously. In method 1, method 2, what we'll do, we'll first find omega by usual method, relative normal speed or separation, and then use any one of these two formulas to obtain y1. So we have determined omega first. Angular velocity of drum with respect to ground is equal to relative normal speed by separation. Relative normal speed by separation, that is 7v minus 3v by r, separation is r. So relative normal speed becomes 7v minus 3v by r, that is equal to 4v by r in clockwise sense. Okay. In method 2, angular speed becomes 4v by r in clockwise sense. Now we apply any one of these formulas to get y1. Suppose I apply this formula. So velocity of d1 should be omega y1, that is same as 3v. Omega is 4v by r. So 4v by r into y1 is equal to 3v. So y1 becomes 3r by 4. Okay. So 3r by 4 below d1 is the required answer. Alright, fine. Now we solve this by method 3. How to solve this by method 3 is the question. Okay. So we solve by method 3 in this way. By method 3 we solve in this way. IC of drum with respect to ground is at a distance v d1g by omega along the direction, distance this from d1 along the direction omega cross v d1g. Okay. So now first we determine this quantity v d1g by omega. Now what is v d1g? V d1g is nothing but 3v. And omega we have determined already. Omega is how much? Omega is 4v by r. So this becomes 3r by 4 from d1. Along which direction? Omega cross v d1g. Now omega, since omega is clockwise, so direction of omega is cross. And v d1g is what? Rightward. Omega is this. So v omega cross v d1g. V d1g is rightward. Omega is clockwise, so inward. Omega cross v d1g is downward. So this IC is 3r by 4 below d1. Okay. So IC of drum with respect to ground is at a distance of 3r by 4 below d1. Okay. It is at a distance of 3r by 4 below d1. There is one answer. Same answer which you obtained by different methods. Okay. Fine. This also error bit now. Okay. Now, by method 4 I solve this. IC of drum with respect to ground is at a distance of VCG by omega d along the direction distance of from C along omega d cross VCG. Now first you evaluate this distance VCG by omega d. VCG is what? 7V. Omega d, omega is what? 4V by r, as we determined. So 7r by 4. Okay, along the direction omega d cross VCG. Now omega of drum is clockwise sense, so direction is cross into the plane of board. And VCG is what? Rightward. Omega is inward, VCG is rightward. Omega cross VCG is downward. So IC of drum with respect to ground is at a distance of 7r by 4 below C. That is 7r by 4 minus r, 3r by 4 below D1. Same answer we have obtained again. Okay, so is a distance of 7r by 4 below C. That is at a distance of 3r by 4 below D1. Okay, this is therefore the required answer. So IC of drum with respect to ground is at a distance of 3r by 4 below D1. That is the same answer which you obtained by remaining methods also. Fine. Hear about this. Now let's take part B of this question. Part B, what we have to do? We have to determine the IC of drum with respect to plank. That also by several different methods. So now again, when we have to determine the IC of drum with respect to plank, all the velocities and angular velocities must be taken with respect to plank. So first what we do, we determine the velocity of C and D1 of material point C and D1 of the drum with respect to plank. So using the formula for translating frame, because plank translates with respect to ground. So we write VCG is equal to VCD plus VDG. VCP plus VPG, P for plank, C for center, G for ground. So this means VCP becomes VCG minus VPG. Okay, so this becomes VCG plus minus of VPG. Okay, so VCG is how much? This is 7V rightward and VPG is V rightward, minus VPG becomes V leftward. We have to vectorially add these two quantities. This will be from parallelogram law, it will be 6V rightward. Okay, VCP becomes 6V rightward. Now we have to find VD1P. We again use the formula for translating frame. VD1G is equal to VD1P plus VPG. Alright, so from this it follows that VD1P is same as VD1G minus VPG. Now VD1G is how much? VD1G is nothing but 3V rightward. And VPG is what? VPG is V rightward. So minus VPG becomes V leftward, and this becomes 3V rightward. Vectors of these two from parallelogram law will be 2V rightward. Okay. All right. Fine. So now this is the situation. With respect to plank, center C has a speed of how much? 6V rightward, and D1 point of the drum has a velocity of how much? That has a velocity of 2V. That also rightward with respect to plank. Both these velocities are with respect to plank. Both are 6V rightward and 2V rightward. Both these velocities are with respect to plank. Alright, fine. Alright. This I'll rub it now. So see. Now we have to determine the location of IC of drum with respect to plank by several methods. First we do by method 1. Consider the line CD1. See, with respect to plank, center C has a speed of 6V and D1 has a speed of 2V with respect to plank. See, IC is that point of drum which has a zero velocity. So as we move downward, speed is decreasing, 6V decreases to 2V. So velocity of zero velocity point should be below D1, somewhere here. Here the IC of drum should lie. This is 6V. As we move downwards, speed goes on decreasing. Here it becomes 2V rightward. Here it was 6v, right? Here it becomes 2v, right? So as you move down, speed goes on decreasing. So at some distance y1 below d1, what happens? The velocity vanishes. That is the IC by definition. Now we have to determine y1. Okay. Now question is how to find this y1. Again, we use the IC concept. Okay. So now center C is at a distance of r plus y1 from IC. Okay. And let omega 1 be the angular velocity of drum with respect to Planck. Because as I mentioned just now, when we are finding the IC of drum with respect to Planck, then all the angular velocities also have to be taken with respect to Planck. In the previous we found omega of drum with respect to ground, but now we want omega of drum with respect to Planck. So what do we say? Let omega 1 be the angular velocity of drum with respect to Planck. Okay. Now center is at what distance from IC? R plus y1. So speed of center is omega into r plus y1. Omega 1 into r plus y1. That is same as 6v. And d1 is at what distance from IC? y1. The speed of d1 is how much? Omega 1 y1. That is 2v. Now we divide both of them. If we divide both of them, omega 1 goes away. R plus y1 by y1 becomes 6v by 2v, 3. So r plus y1 becomes 3y1. So 2y1 becomes r. y1 becomes r by 2. This is the IC. So IC of drum with respect to Planck is at a distance of r by 2 below the point d1. So this was the method 1. Okay, fine. This I have now. Okay. Now we can solve this by another method M2 also. In another method, what we do, we find omega 1 first. Okay. And then use any one of these two equations to determine y1. That is method 2. So how do you solve that? So in order to solve that, what we do is this. What we do is the following. We first find the angular speed of drum with respect to Planck. We know the formula omega of drum with respect to ground is omega of drum with respect to Planck plus omega of Planck with respect to ground. Now omega of drum with respect to ground is omega, which we have already determined, 4v by r. Okay, 4v by r now in ground frame. And omega of drum with respect to Planck is some omega 1. And omega of Planck with respect to ground is 0 because Planck is translating with respect to ground frame. So this term goes away. So omega of drum with respect to Planck is simply omega of drum with respect to ground. That is how much? 4v by r. Okay. Now, if we use any one of these two formulas, suppose I use this one. So the velocity of omega 1 is 4v by r. d1 is at what distance from IC? y1. So speed of d1 will be what? Speed of d1 will be omega 1 y1. That is same as speed of d1 with respect to Planck. That is how much? 2v. 2v is the speed of d1 with respect to Planck. And omega 1 is 4v by r. 4v by r into y1 is equal to 2v. y1 is equal to r by 2. The same answer is obtained here also. So IC of drum with respect to Planck is at a distance of r by 2 below d1. Okay, this is also clear. Instead of using this formula, I could have used this also in method 2. Then I would have written 4v by r into r plus y1 equal to 6v, and we solve again by we get y1 same value. Okay, alright. Now we solve it by method 3. IC of drum with respect to Planck is at a distance of omega 1 cross VCP, is at a distance of VCP by omega 1 along the direction is at distance of VCP by omega 1 from C along the direction of omega 1 cross VCP. Along the direction of omega 1 cross VCP. Alright. Now first we evaluate this quantity VCP. VCP by omega 1. VCP is just calculated here 6V. And omega 1 is the angular velocity of drum with respect to Planck, that is same as 4V by R. So this becomes 3R by 2. Along this direction, omega 1 plus VCP. Now omega 1 has a clockwise sense. So direction of omega 1 is what? Inward. And VCP is what? Rightward. So omega 1 is inward, VCP is rightward. So omega plus VCP is downward. So IC of the drum with respect to Planck is at a distance of 3R by 2 below center C. That is at a distance of R by 2 below D1. So same answer we have obtained by method 3 also. By using method 3 also, we have obtained the same answer. You can see it. Fine. Now I'll solve this the method 4. Now solve this problem by method 4. Method 4 I use the same concept, but instead of C we use D1. So IC of drum with respect to Planck is at a distance of V D1P by omega 1 from D1 along the direction of omega 1 cross V D1P. First you evaluate this distance. How much is V D1P? That is given to be 2V. And omega 1 we already determined, that is same as omega 4V by R. So this becomes R by 2. R by 2 distance from D1 along this direction. Now it is omega 1 is what? 4V by R clockwise. Direction of sense of omega 1 is clockwise. Direction of omega 1 is cross. And V D1P is what? Rightward. And omega is inward. Omega 1 plus V D1P will be in downward direction. So IC is at a distance of R by 2 below D1. Same answer as we obtained by remaining methods. Okay. So same method we have obtained by all the methods. We are getting the same answer. Okay. So this was the 39th video on rigid body kinematics. Okay. In the 30th video also, 40th video, I'll take a similar problem on this concept. Okay. In the, I think around 3 to 4 videos more I'll make on this rigid body kinematics. And then I'll pass about in Newton's laws of motion. In Newton's laws of motion, there will be 3 phases. First, friction without Newton's laws without friction, then circular motion dynamics. As far as Newton's law is concerned, in first part, that will be a very lengthy video. I think there will be around 100 videos in Newton's law first phase. 100 videos will be there. There's no doubt about it. Okay, so it's extensive. When I'm telling you, the videos which are being made here, they're extensive. They fully cover the syllabus in a rigorous approach. Okay, if you go through them, it's wonderful. You'll solve all of them. There's no doubt about it. Okay, this I close it here. Fine. All right.